7 years old, and your mother finds you standing in the kitchen at 2 in the morning. Your eyes are open. You're not screaming, not stumbling. You're calmly opening the refrigerator, the way you might on any ordinary afternoon. She says your name. You don't answer. A minute later, she guides you back to bed, and in the morning, you remember none of it. If this has ever happened in your family, you probably already suspected something. Because sleepwalking doesn't just happen to random people. It runs. Let's talk about why. Sleepwalking, or somnambulism, isn't a dream you're acting out. It happens during deep, non-REM sleep, the dreamless stage where your brain produces slow, synchronized waves. What actually happens is stranger than a dream. Part of your brain wakes up enough to move your body, walk you down a hallway, even hold a conversation, while the part responsible for conscious awareness and memory formation stays almost entirely offline. You are, in a very real sense, partially awake and partially asleep at the same time. And here's the reframe: if you've ever sleepwalked, and one of your parents did too, that's not a coincidence. Researchers have found that children of sleepwalkers are roughly 10 times more likely to sleepwalk themselves than children with no family history at all. 10 times. That's not the kind of number you get from shared habits or a stressful childhood. That's the kind of number that points somewhere much deeper, your DNA. In 1997, researchers Christer Hublin, Jaakko Caprio, Markku Partinen, Kauko Heikkilä, and Markku Kaskanvuo published a large population-based twin study in the journal Neurology. Twin studies are one of science's cleanest tools for separating genetics from environment, because identical twins share essentially all their DNA, while fraternal twins share only about half, like ordinary siblings. If a trait were purely about upbringing, identical and fraternal twins should resemble each other about equally. That is not what the researchers found. Adult sleepwalking turned out to be roughly 5 times more common among identical twins than fraternal twins, a striking signal that genetics, not just a shared bedroom or shared parents, was driving much of the risk. But knowing something is heritable is different from knowing why. For years, sleepwalking's genetic roots remained a total mystery. Then, in 2003, geneticist Mehdi Tofti at Geneva University, working with colleagues Michel Lesendrus, Claudio Bassetti, Yves Dovaliers, Geert Meyer, and Enrico Neidhart, published a study in the journal Molecular Psychiatry that pointed to an unexpected suspect, a gene called HLA-DQB1. If that name sounds unfamiliar, here's the plain English version: HLA genes are part of your immune system. Their normal job is to help your body's defenses recognize which cells belong to you and which don't, so they can attack foreign invaders like viruses without attacking you. Tofti's team studied 60 people with sleepwalking, along with their families, and 60 people without any sleep disorder. People carrying one particular version of this immune system gene were 3.5 times more likely to be sleepwalkers. Here's where it gets stranger. Why would a gene built for fighting infections have anything to do with getting up and walking around at night? Tofti's own theory is that in some sleepwalkers, this immune system gene may not be attacking a virus at all. It may be mistakenly targeting cells involved in regulating sleep itself, the same way certain immune-related genes have already been linked to narcolepsy, another sleep disorder with a strong genetic and immune component. In other words, for at least some families, sleepwalking might not be purely a brain wiring problem. It might be, in part, a case of your own immune system quietly interfering with the machinery that's supposed to keep you fully asleep or fully awake, and never in between. So let's reconstruct what might actually be happening on one of those nights. You fall asleep, and within the first couple of hours, your brain drops into its deepest non-REM stage, the stage where those slow brainwaves dominate and your body is at its most still. In most people, that stage stays contained, deep sleep for a while, then a natural drift back toward lighter sleep and eventual REM. But in a brain wired by certain genetic variants, and possibly nudged by this immune-related gene, that transition doesn't stay clean. Part of the brain, the part governing movement and basic behavior, partially rouses. The part responsible for higher awareness, judgment, and memory encoding stays suppressed. The result is a body that can walk, open doors, sometimes even respond to simple questions, tethered to a mind that isn't recording any of it and won't remember a thing by morning. In 2011, a research team led by A.K. Lysis studied a 4-generation family in which sleepwalking had been passed down again and again, published in the journal Neurology. 9 family members had a documented history of sleepwalking, 13 did not. By comparing their DNA, the researchers traced the condition in this particular family to a specific stretch of chromosome 20, and found that sleepwalking behaved almost like a classic inherited trait, passed down as what geneticists call an autosomal dominant condition, meaning a single copy of the variant, from just one parent, was enough to significantly raise the risk in that family. That doesn't mean everyone's sleepwalking traces to that exact spot on chromosome 20. Different families carry different genetic contributors, which is part of why sleepwalking has been so difficult to fully map. But across study after study, the pattern holds: this is not a habit. It's not just stress. For a large share of people who sleepwalk, it's written, at least partly, into their genome. And that reframes something important about how sleepwalking gets treated, both medically and socially. Because here's the twist worth sitting with: sleepwalking is still widely treated as a quirky story to tell at parties, or a childhood phase people are expected to simply outgrow. But when children of sleepwalkers face those 10 times higher odds, and identical twins show that dramatically stronger match, this stops looking like coincidence and starts looking like biology working exactly as biology does, quietly, predictably, running through a family line the same way eye color or a tendency toward migraines might. Think about what that means if sleepwalking runs in your family. It means the 2 a.m. kitchen visit, the sleepwalking teenager, the parent who once wandered into the hallway and back without ever waking up, aren't separate, unrelated stories. They may be the same underlying biology, expressing itself across generations, sometimes through a stretch of chromosome 20, sometimes through an immune gene that was never built for this job in the first place, quietly reaching into a part of the brain no one asked it to touch. You don't get to choose your genes, and if sleepwalking runs in your family, you didn't do anything to cause it, and neither did your child. What you inherited wasn't carelessness or an overactive imagination. It was a specific, traceable piece of biology, hiding in plain sight for generations until scientists finally had the tools to go looking for it. So the next time someone in your family gets up in the middle of the night, walks somewhere, and remembers nothing about it in the morning, you'll know it's not really a mystery. It's a message, written in DNA long before that person was ever born, quietly making its way down the family line, one sleeping generation at a time.